Question 1 said, evaluate limit x approaching to 0, 1 over sine x minus 1 over x squared. And then, what we have to do is, step 1, we have to change to single fraction first. Okay. To change to single fraction, we have to same the denominator first, and for 1 over sine x, we multiply with x squared for both upper and lower part, and same goes with 1 over x squared, we multiply with sine x for upper and lower part, and then we get the answer limit x approaching to 0, x squared minus sine x over x squared sine x. Okay, what we have to do next? Step 2 is, we have to check the limit, either the limit we get 0 over 0 or infinity over infinity. Okay, for limit x approaching to 0, we check and we insert x equal to 0, and then we get 0 over 0. Okay, when we get 0 over 0, we have to use L'Hospital rule as step 3. Okay, to use L'Hospital rule, we have to differentiate x squared minus sine x, and we have to differentiate x squared sine x. Okay, firstly, we differentiate x squared minus sine x. Using power rule, we get 2x minus cos x, and then we differentiate x squared sine x, we get use product rule. So we use product rule to differentiate x squared sine x, and then we have to let u equal to x squared, and u prime we get 2x, and we have to let v equal to sine x, and we get v prime equal to cos x. Equation for product rule, we use uv prime plus vu prime, and then we get the answer is x squared cos x plus 2x sin x. And then we get the value limit x approaching to 0, 2x minus cos x over x squared cos x plus 2x sin x. Step 4 is we insert x approaching to 0 to get the value, or we want to get the answer. Okay, we insert x equal to 0, and then we get negative 1 over 0, and lastly the answer is negative infinity.
Assalamualaikum. So for question 2, the question asks us to find the velocity of the object after a very long period. Okay, so what we have to do is we have to put all together the information that is given. So the first information given is the velocity of an object at 0 time is equal to 0. Next, the question also gives us the velocity of object at time t is given by this equation, which is vt equal to mg over a 1 minus the exponent power of negative kt over m. Okay, so this equation is derived from the differential equation given, which is m dv over dt plus kv equal to md. Okay, so we go back to what we want to know and what we want to calculate. We want to calculate the velocity of object after a very long period. Okay, so this is the step to solve the equation. So first of all, from the equation, it means that we doesn't know the exact time that we want to calculate. So from the equation of the velocity of object at time t, we can know the velocity after a very long period. We will take limit for both sides. Limit t it approach infinity because we doesn't know the time. V equal to limit t approach infinity mg over a. 1 minus exponent negative kt over m. So as we know that mg over a is constant, so we will put mg over a in front of limit t approach Then we will put exponent this as denominator because we want to positive the value of power. Okay. Next, as we see, this is the difference in determinate form. So to solve this equation, we have to get single fraction by make the same value of denominator. Okay, to get the single fraction. Okay, and we have get the same value of denominator, and here is the simplest form of fraction. Okay, so next we try to substitute p equal to infinity to the equation. So what we will get, the answer is infinity over infinity. So this is not the right answer. What we have to do is, to solve this question, we have to apply L'Hospital rule. So L'Hospital rules means we have to differentiate the limit t approach infinity. So we will differentiate both denominator and also numerator. We will differentiate the exponents and we will get this answer. So from here we can see that numerator and denominator is same value. So we can cancel out this and we will get the value 1. Okay. So as we see in this equation, there is no t. So we doesn't have to substitute infinity in this equation. So the answer that we will get is v equal to mg over a. So the conclusion is the velocity of object after a very long period is equal to v equal to mass of object times gravitational constant over constants of proportionality.
Question 3. Given that the function of f(x) is equal to ln x over square root x, find integrate function of f(x) dx and evaluate integrate 0,1 function of f(x) dx. The question given is the function of f(x) is ln x over square root x. The first step we should do is isolate the equation, which is 1 over square root x multiply with ln x. 1 over square root of x can be written as 1 over x power of 1 over 2. To eliminate the fraction, we write the equation as x power of negative 1 over 2 multiply with ln x. So the equation become integrate x power of negative 1 over 2 ln x. The second step is we use the by-part rule to solve this equation, which is integrate u dv is equal to uv minus integrate v du. First, we should know what is u and what is dv. In these cases, ln x is a u while x power of negative 1 over 2 is dv. We differentiate the ln x and it become 1 over x, while for dv, we integrate the x power of negative 1 over 2 and it become 2x power of 1 over 2. So the third step is we use the by-part rule, which is integrate u dv is equal to uv minus v du. We just substitute in the equation, which is ln x 2x power of 1 over 2 minus integrate 2x power of 1 over 2 multiply with 1 over x dx. After we integrate the equation, the final answer we get is 2 square root of x ln x minus 4 square root x plus c. Hence, evaluate integrate 01 fx dx. So, integrate 01 ln x over square root x is equal to limit a is equal to 0. Integrate 01 ln x over square root x. After we integrate the equation, we substitute the variable x with 1 and a. So the final answer we get is -4.
Okay, we continue for the question 4. Question 4 says, determine how large the number row has to be so that row approach to positive infinity 1 over x squared plus 1 dx less than 1 over 1000. How to solve this question? Okay, so let's go and see. Step 1. An improper integral like this where we have an infinity symbol, we need use a limit expression. So this expression is equivalent to the limit as let b equal to positive infinity. So we replace positive infinity with b like this. Step 2. We need to integrate this equation. After we integrate this equation, we get this value. We use the inverse trigonometry. After that, we need to substitute value of b and rho into x. After we substitute the value, we get this answer. After that, we need to change the value of b with infinity. Inverse times infinity, we get pi over 2. It is because we use the principal value of r tan infinity. Tan goes to negative infinity at negative pi over 2 and tan goes to infinity at pi over 2. And we get this answer. After that, we need to test how large the number row. We need to substitute the answer into the equation like this, and we need to simplify to get the value of row. After we simplify, we get the value of row equal to row more greater than 999.99. After that, we need to round off the value of row and get the final answer row greater than or equal to the 1000. This is a final answer. That's all from us. Thank you for watching our video.